So in our last video, we talked about arrays. The downside to the array is that you have to specify a size, and then you're limited to that size. You can't go beyond it. And to overcome that, we can use a list. List is a type of collection in C#, and C# actually has generic and non-generic. And generic collections are strongly typed, which means you have to specify the data type. They don't have a specific size, which allows you to add and remove items. So the size is dynamic. So this is considered to be a dynamic array, even though it's called a list. The primary difference, again, between a list and an array is that you can add and remove items. And then there's also some kind of nifty little methods that you can use that sort the list. And you can actually combine arrays with lists. There's lots of different methods you can use with the list. So we're going to take a little closer look at a list. And to pull the methods and properties into your program, you have to include using system collections.generic. Now, if you just have using system, that should work because collections.generic is part of system. Okay, but it's the more specific you are, the more efficient your program is going to run. Because all we really need is the generic collection. We don't need everything else. Okay, so yes, using system will work. Is using system.collections.generic better? Yes, it's better. So we're going to take a little closer look at a list. To declare one, you have to use the keyword list followed by the data type in angle brackets. The angle brackets are required. Just like regular brackets are required for arrays, angle brackets are required for lists. And then you give the object a name, and then you say new list, and then in angle brackets, you have your data type. You may or may not include numbers or values in an initializer list, but that would be in curly braces. So even if you don't put values in, you can include empty curly braces. And that is what these two examples are showing. So one is showing how to create an integer list, and the other one is showing how to do a member string list. Now, how do we get data into a list? Well, we can use initializers. Okay, so inside those curly braces, you can put values. Just remember that the values have to match the data type that you use to declare the list. So here is an example of an integer list and a string list with initialization values. Another way to add items to your list is to use an add method. So you have to take your list object name, a dot, and then add, and the A is capitalized. And then in parentheses is the value that you want to add. Now, can you create a variable and add the variable? Yes, as long as the variable is the correct data type. So in this little example, members is a string list, and I'm trying to add something called temp name, which is also a string. So yes, I can do that. By default, the add method adds them to the end of the list. Okay, well, what happens if you want the item added to the beginning of the list or somewhere else in the list? You don't want it at the end. You can use the insert method. So with the insert method, you are giving it the index a comma, and then whatever the value is. So it's the object, your list object dot insert, and then you're giving it the index and the value. And this lets you insert wherever you want. Okay, so any specific location at the beginning, you would index in with 0, okay, but you can use insert. Another way to add values. If you have an array and you would like to add the array values to your list, as long as the data types are the same, you can use add range. So with add range, it's your list object dot add range, and then in parentheses is the name of the array that you want to add. Okay, so this little example just shows I have a list called members, and then I've got a string array called member array, and I am adding the member array to the bottom of my members list. And then I do the same thing with scores, which is integer. The list collection uses count to retrieve the size. It does not use length. Length is for arrays. So the list uses count. And knowing the size is kind of important because you don't specify a size. With a list, it's whatever size, however many number of items are in it. So count becomes kind of important when you are dealing with a list. And to use this, it's just your list object name dot count. Okay, and then you have a left and right parenthesis. So knowing that you can use count, that does allow you to do a for loop. With the for loop, remember, you're going to stay in the loop for as many items are in your array. So that becomes the list object name dot count. And that's the number of items that are in that list. For each works great because it automatically processes every single thing in the list. Okay, so you can use both. For sorting, you can sort in ascending or descending order. So the list object name dot sort is ascending, and the list object name dot reverse is descending. Okay, so I have examples here of how you would sort and print the member string array. So we've talked about the different ways of adding to the array. We've looked at the for each and the for to process these lists. And now we're going to take a look at how to remove items from your list. So to remove from the list, you can simply say remove. And if you use remove, it's just your list object name dot remove. And then in parentheses, you can either give it the value that you want to remove, or you can give it the list with the index, which is basically the position that you want to remove. So you can use remove. You can also use remove at, which if you know the position, I think remove at works better because it's just the list dot remove at, and then you just give it the index. You don't even have to give it the list. If you wanted to remove more than one thing, you can remove a range. So if you're going to remove a range, it's the list name dot remove range. You have to give it the beginning index where it needs to start removing from, a comma, and then the number of items to remove. So I've got this little example that you can run, and you can see I create a list, and then I've got like a temporary variable that I use to add to the list. And then I'm using insert to add to the beginning. And then I've got the original list has, and then I'm printing out how many members are in this list, which at this point should be 6. Okay, and then I create a little array, and I combine the list and the array. And then I'm printing out how many members it has now. Well, I added 4, so it should be at 10. Okay, and then I am printing out all 10 members of the list. And then I remove Pete, and then I'm removing the member that's at index 4. And then I'm also removing a range starting at index 3, and I'm removing 2. And then I print out the number of items that are now in the list. And then I print out each of those items. And then I take the list and I sort it in ascending order, print that out, sort it in descending order, print that out. If you need to empty the list, you can use the clear method. So it's just your list name dot clear. So I do have an example where I have an integer array and I go through all of the gymnastics, right? I add to it, I insert at a specific point. I've got a score array that I combine with my list. Okay, I write things out to the console, I sort it, I write out the sorted range, sorted items, and then I start removing items. So I remove a range, which is 4 items that were in my list, and I remove a specific value. And then you can see that I print out the revised list. And after I print out the revised list, I clear everything out. Then I add 2 values and indicate the previous scores were erased, and then I print out the new list with the 2 values. So this is something that you can run if you want to copy it. I did put the output here so you can kind of go through and see how it works. I do have another example here. And this example is dealing with money again. And I decided to show you guys how to use formatted output here, or how it looks. The next video will explain how to code the formatted value in a little bit more detail. But if you look through here, you can see that we are storing the name of the account in a string. Then we've got the beginning balance that we are storing, and we set the ending balance to the beginning balance. And then we have our list, and we're calling it account. And we add the beginning balance to the first element, which is index 0. And then we ask them how many checks they want, get into this little loop where they're going to add checks to our account as well. And so you can see we're asking them to enter the check. We're storing it in temp check. We are subtracting from the ending balance, and we're adding temp check to our account list. And then once we're out of that loop, we know what the ending balance is, so we add that. So the way this looks when it is running is we've got the account name, which we have filled in. We'll say Fred Flintstone. Okay, and then we've got account, we've got beginning balance, ending balance, And then we've got the account. And so at position 0, we have our beginning balance. So we'll just do something easy like 1,000. Okay. So position 0 is 1,000. And then we added some checks. So let's say we added 2 checks. 450 and let's say we did 50. Okay. So while we were adding those checks, we were subtracting from ending balance. So ending balance started at 1,000. Then we subtracted out 450, which gave us 550. And then we subtracted from that 50, which gives us 500. Okay, so we add that 500 here. So then account at the end here is equal to 500. All right, so then we have a little right line. Here's your account activity. We got the little squiggly. And so then we've got Fred Flintstone here. And then beginning balance. All right, so now we are at this point, string format. So normally it would just be printing out 1,000, but you can see here I've concatenated it with this formatting. So this is a custom format, and they always start with 0 and a colon, and then the actual format that you want follows. So I want a comma in the thousands place, and I want 2 decimals. So what it's going to print out is that, which is a little bit more user-friendly than just a 1 and 4 zeros. Okay, so now I want to print out all of my checks. I've already printed this. Okay, so for my index, I don't want to set it to 0. I want to set it to 1, which is what I do. Okay, and then I'm going to stay in here. Well, I want to stay in here to print out my checks, but I don't want to print the ending balance. So what I want is account.count minus 1. Okay, so I basically account.count is going to give me my total number of items, okay, which is 4. But I'm going to subtract 1 and have it check for 3. So I'm going to have I starting at 1. And I'm going to stay in here as long as I is less than 3. Okay, and then it's going to write to the council, check amount. It's going to be putting that right up here. And you'll notice that because the check amounts are smaller, I changed the format. We don't need the thousands placeholder. So I just have 2 digits dot 2 digits. Okay, and it's going to grab account I. So the first time through, account I is a 1. So it's going to do 450. Oops. Hit the wrong key. Okay. Right, then we go to the top of the loop. I changes to a 2. Okay. And so 2 is still less than 3, right? So we do this again. And now it comes up here and it's retrieving 50. Okay, then we go back to the top of the loop, add 1. Now I is a 3. Is 3 less than 3? No. So it falls out of the loop. Okay, and then it's going to print ending balance. And then for our string format, we're back to using the 1000 placeholder. And what we are subscripting in with is account.count -1, which is going to give us this last entry. Okay, so that is how it is processing. And you can kind of follow it here. So that concludes lists. The next video is going to cover formatted output and scope.